The digitized sine wave assignment. Here's the front panel. I just made the font size a little bigger, make it easier to see. There's the block diagram. The oscilloscope is hooked up. Nothing's on currently. The DAQ is hooked up to A0 for output and ground. The main line of the oscilloscope is hooked up to the A0 output, and the secondary one that's hooked up with the little claw is hooked up to the ground. And now I'm going to run the VI. And when I run the VI, you'll see a digitized sine wave out of 14 different steps. If I make it fewer, you'll see fewer steps to make the sine wave. That's at 8. And if I show both at the same time, you can see the changes. And that's at 4. And if I go to a lot of samples, so you take the sine wave, 25 samples, it looks close to a sine wave. So 25 individual steps to make a sine wave. Now if I keep on going up to 50, as you can see, it looks like a nice sine wave. It changes the wavelength a little bit. And you can see there, you can just barely see the steps involved. So it looks like a really close sine wave. If you sample it 50 times a wave, or make it into 50 little steps, and use that's how digital can look like analog. And if I make it even more, let's go here to 100. And I look at it, it looks nice and smooth. But if you think about it, if you put 100 little steps over one sine wave, steps would be so small it might be hard to see. And let's see if we can see them by changing the scale a little bit. See them a little bit here. I change the position. Right here. Now you can start seeing them just a little. But you really have to look close at the sine wave, and that's just a part of it, to see the individual steps. So digitizing a sine wave, front panel, block diagram, output, and if we keep on going down, that's just aliasing from me changing it constantly. So we're going back down to and we start to see a digitized sine wave out of individual steps. This one's at 28. And we move that up here a little bit. And as before. All right. Make it happen.